Enumerating the public network. We'll start with the first step of our penetration test, enumeration. Our fictitious client has provided us with two initial targets, which we can access via the PEN 200 VPN. Let's review a network overview based on the client's information. There are two accessible machines, WebServe1 and MailServe1, as well as their corresponding IP addresses. In the first section, we'll begin by setting up a basic network environment for our penetration test, and then enumerate MailServe1. MailServe1. Before we begin to interact with our target to enumerate it, let's set up a work environment for this penetration test. This will help us to store obtained files and information in a structured way throughout the assessment. In later phases of a penetration test, this will prove especially helpful as we'll collect a huge amount of data and information. For this reason, let's create a home Kali beyond directory on our Kali VM. In it, we'll create two directories named after the two target machines we have access to at the moment. In addition, we'll create a creds.txt text file to keep track of identified valid credentials and users. Now that we've set up a work environment, we're ready to enumerate the first target machine, MailServe1. Let's begin with a port scan of MailServe1 using Nmap. A port scan is often the first active information gathering method we'll perform to get an overview of open ports and accessible services. We'll use -SV to enable service and version detection, as well as -SC to use Nmap's default scripts. In addition, we'll enter -ON to create an output file containing the scan results. Nmap discovered 8 open ports. Based on this information, we can establish that the target machine is a Windows system running an IIS web server and an HMail server. This is not surprising as the machine is named MailServe1 in the topology provided by the client. Since we may not be familiar with HMail server, we can research this application by browsing to the application's web page. It states that HMail server is a free, open-source email server for Microsoft Windows. To identify potential vulnerabilities in HMail server, we can use a search engine to find CVEs and public exploits. However, as Nmap didn't discover a version number, we have to conduct a broader search. Unfortunately, the search didn't provide any meaningful results apart from some older CVEs. Next, let's enumerate the IIS web server. First, we'll browse to the web page. The page shows that IIS only displays the default welcome page. Let's try to identify directories and files by using GoBuster. we'll enter dir to use directory enumeration mode, -u for the URL, -w for a word list, and -x for file types we want to identify. For this example, we'll enter txt, PDF, and config to identify potential documents or configuration files. In addition, we'll use -o to create an output file. The output shows that GoBuster did not identify any pages, files, or directories. Let's summarize the information we've obtained while enumerating MailServe-1 so far. First, we launched a port scan with Nmap, which identified a running IIS web server and HMail server. In addition, we established that the target is running Windows, then enumerated the running web server more closely. Unfortunately, this didn't provide any actionable information for us. We cannot use the mail server at this moment. If we identify valid credentials and targets later on in the penetration test, we could perhaps use the mail server to send a phishing email, for example. This cyclical nature of a penetration test is an important concept for us to grasp because it provides a mindset of continuously reevaluating and including new information in order to follow previously inapproachable or newly identified attack vectors. WebServe-1. In this section, we'll enumerate the second target machine from the client's topology, WebServe-1. Based on the name, we can assume that we'll discover a web server of some kind. As before, we'll begin with an Nmap scan of the target machine. The Nmap scan revealed only 2 open ports, 22 and 80. Nmap fingerprinted the services as running an SSH service and HTTP service on the ports, respectively. From the SSH banner, we retrieve the information that the target is running an Ubuntu Linux system. However, the banner provides much more detail with a bit of manual work. Let's copy the OpenSSH 8.9p1 Ubuntu 3 string into a search engine. The results contain a link to the Ubuntu Launchpad web page, which contains a list of OpenSSH version information mapped to specific Ubuntu releases. In our example, the version is mapped to Jammy Jellyfish, which is the version name for Ubuntu 22.04. For port 22, we currently only have the option to perform a password attack. Because we don't have any username or password information, we should analyze other services first. Therefore, let's enumerate port 80 running Apache 2.4.52. We'll begin by browsing to the web page. Because the Nmap scan provided the HTTP title Beyond Finances, our chances of encountering a non-default page again are high. A basic company web page populates. However, if we review the website, we'll notice it doesn't contain a menu bar or links to other pages. At first glance, there seems to be nothing actionable for us. Let's inspect the web page's source code to determine the technology being used by right-clicking in our browser and selecting View Page Source. For a majority of frameworks and web solutions, such as CMSs, we can find artifacts and string indicators in the source code. Let's browse through the source code to examine the page's header, comments, and links. At the bottom, we'll find some links. We notice that the links contain the strings WP content and WP includes. By entering these keywords in a search engine, we can establish that the page uses WordPress. To confirm this and potentially provide more information about the technology stack in use, we can use WhatWeb. The output confirms that the web page uses WordPress 6.0.2. While the WordPress core itself has had its share of vulnerabilities, the WordPress developers are quick to patch them. A review of the release history for WordPress indicates this version was released in August 2022, and at the time of this module, it's the most current version. However, WordPress themes and plugins are written by the community, and many vulnerabilities are improperly patched or simply never fixed at all. This makes plugins and themes a great target for compromise. Let's perform a scan on these components with WP Scan, a WordPress vulnerability scanner. This tool attempts to determine the WordPress versions, themes, and plugins, as well as their vulnerabilities. WP Scan looks up component vulnerabilities in the WordPress vulnerability database, which requires an API token. A limited API key can be obtained for free by registering an account on the WP Scan homepage. However, even without providing an API key, WP Scan is a great tool to enumerate WordPress instances. To perform the scan without an API key, we'll provide the URL of the target for URL, set the plugin detection to aggressive, and specify to enumerate all popular plugins by entering P as an argument to enumerate. In addition, we'll use -O to create an output file. The output shows the WP Scan discovered 6 active plugins in the target WordPress instance: Akismet, Classic Editor, Contact Form 7, Duplicator, Elementor, and WordPress SEO. The output also states that the Duplicator plugin version is outdated. Instead of using WP Scan's vulnerability database, let's use SearchSploit to find possible exploits for vulnerabilities in the installed plugins. For a majority of the identified plugins, WP-Scan provided us with the detected versions. Because most of the plugins are up to date and no version could be detected for a Kismet, let's start with Duplicator. The output shows that there are 2 exploits matching the version of the Duplicator plugin on WebServe 1. One is tagged with Metasploit, indicating that this exploit was developed for the Metasploit framework. We'll review these exploits in the next learning unit. Let's summarize the information we obtained about WebServe 1 in this section. We learned that the target machine is an Ubuntu 22.04 system with 2 open ports, 22 and 80. A WordPress instance runs on port 80 with various active plugins. A plugin named Duplicator is outdated, and a searchsploit query provided us with 2 vulnerability entries matching the version. Initial foothold. In the previous learning unit, we used searchsploit to find exploits for Duplicator 1.3.26. Searchsploit provided 2 exploits for this version, one of which was an exploit for Metasploit. Let's use searchsploit to examine the other displayed exploit by providing the exploit DB ID to -X. Once we press Enter, the information and exploit code for a directory traversal attack on Duplicator 1.3.26 are shown. This output shows the Python code to exploit the vulnerability tracked as CVE 2020-11738. Notice that the Python script sends a GET request to a URL and adds a file name prepended with /expressions. Let's copy the Python script to the home, Kali, beyond, WebServe1 directory using searchsploit's -M option with the exploit DB ID. To use the script, we have to provide the URL of our target and the file we want to retrieve. Let's attempt to read and display the contents of etc password, both to confirm that the target is indeed vulnerable and to obtain user account names of the system. Very nice. We successfully obtained the contents of etc password and identified 2 user accounts, Daniela and Marcus. Let's add them to creds.txt. As we learned in the Common Web Application Attacks module, there are several files we can attempt to retrieve via directory traversal in order to obtain access to a system. One of the most common methods is to retrieve an SSH private key configured with permissions that are too open. In this example, we'll attempt to retrieve an SSH private key with the name ID RSA. The name will differ depending on the specified type when creating an SSH private key with SSH keygen. For example, when choosing ECDSA as the type, the resulting SSH private key is named ID ECDSA by default. Let's check for SSH private keys with the name ID RSA in the home directories of Daniela and Marcus. We have successfully retrieved the SSH private key of Daniela. Let's save the key in a file named ID RSA in the current directory. Next, let's attempt to leverage this key to access WebServe1 as Daniela via SSH. To do so, we have to modify the file permissions, as we have done several times in this course. The output shows that the SSH private key is protected by a passphrase. Therefore, let's attempt to crack it using SSH to John and John with the rocku.txt word list. After a few moments, the cracking attempt is successful. Now, let's attempt to access the system again via SSH by providing the passphrase. Success! We gained access to the first target in the penetration test. Before we head into the next section, where we'll perform post-exploitation enumeration, let's make sure to add the cracked passphrase to the creds.txt file in the work environment directory. As users tend to reuse passwords and passphrases, we may need it again later in this assessment. A link to the past. In the previous section, we gained access to the target machine WebServe1. In this section, we'll perform local enumeration to identify attack vectors and sensitive information and attempt to elevate our privileges. Because we often have time constraints in a penetration test, such as the duration of an assessment, let's use the LinP's automated Linux enumeration script to obtain a broad variety of information and identify any potential low-hanging fruit. To do this, let's copy linps.sh to the WebServe1 directory and start a Python 3 web server to serve it. In our SSH session, we can use wget to download the enumeration script. In addition, we'll use chmod to make the script executable. Now, we can run the script and start the enumeration. Let's review some of the results. We'll begin with the system information. The output confirms that the machine is running Ubuntu 22.04 as we've identified via the OpenSSH service version. Next, we'll review the network interfaces. The output shows only one network interface apart from the loopback interface. This means that the target machine is not connected to the internal network, and we cannot use it as a pivot point. Since we have already enumerated mail serve 1 without any actionable results, and this machine is not connected to the internal network, we have to discover sensitive information, such as credentials, to get a foothold in the internal network. To obtain files and data from other users and the system, we'll make elevating our privileges our priority. The following results section from LinPs contains an interesting piece of information regarding commands executable with sudo. User Daniela can run user bin git with sudo privileges without entering a password. Before we try to leverage this finding into privilege escalation, let's finish reviewing the LinPs results. Otherwise, we may miss some crucial findings. The next interesting section is analyzing WordPress files, which contains a clear text password used for database access. Discovering a clear text password is always a potential high-value finding. Let's make sure to save the password in the creds.txt file on our Kali machine for future use. Another interesting aspect of this finding is the path displayed that starts with srv www WordPress. The WordPress instance is not installed in var www html, where web applications are commonly found on Debian-based Linux systems. While this is not an actionable result, we should keep it in mind for future steps. Let's continue reviewing the results. In the Analyzing GitHub Files section, we'll find that the WordPress directory is a Git repository. Based on the output, we can assume that Git is used as the version control system for the WordPress instance. Reviewing the commits of the Git repository may allow us to identify changes in configuration data and sensitive information such as passwords. The directory is owned by root and is not readable by other users. However, we can leverage sudo to use git commands in a privileged context and therefore search the repository for sensitive information. For now, let's skip the rest of the LinPs output and summarize what information and potential privilege escalation vectors we've gathered so far. WebServe 1 runs Ubuntu 22.04 and is not connected to the internal network. The sudoers file contains an entry allowing Daniela to run user bin git with elevated privileges without providing a password. In addition, we learned that the WordPress directory is a Git repository. Finally, we obtained a clear text password in the database connection settings for WordPress. Based on this information, we can define 3 potential privilege escalation vectors. 1. Abuse the sudo user bin git command. 2. Use sudo to search the Git repository. 3. Attempt to access other users with the WordPress database password. The most promising vector at the moment is to abuse the sudo user bin git command because we don't have to enter a password. Most commands that run with sudo can be abused to obtain an interactive shell with elevated privileges. To find potential abuses when a binary such as git is allowed to run with sudo, we can consult GTFO bins. On this page, we enter Git in the search bar and select it in the list. Then, let's scroll down until we reach the sudo section. Here are 2 of the 5 potential abuse vectors to elevate privileges via Git with sudo privileges. Let's try the first one by setting an environment variable that executes when launching the Help menu. Unfortunately, the output states that we are not allowed to set an environment variable. Next, let's try the second abuse vector. This command opens the Help menu in the default pager. In Linux, one of the most popular pagers is less. The commands to navigate the pager are similar to VI and can be used to execute code in the context of the user account that launched the pager. To execute code through the pager, we can enter exclamation point followed by a command or path to an executable file. We can enter a path to a shell. Let's use bin bash to obtain an interactive shell. Nice! We successfully elevated our privileges on WebServe 1. Armed with root privileges, we'll continue enumerating the system. Before doing so, let's search the Git repository for sensitive information first. To do so, we'll change our current directory to the Git repository. Then, we can use git status to display the state of the Git working directory and git log to show the commit history. The output shows that there are 2 commits in the repository. One is labeled as initial commit and one as removed staging script and internal network access. That's quite interesting, as it indicates that the machine previously had access to the internal network. In addition, the first commit may contain a staging script that was removed. We could switch back to a specific commit by using git checkout and a commit hash. However, this could break the functionality of the web application and potentially disrupt the client's day-to-day operations. A better approach is to use git show, which shows differences between commits. In our case, we'll supply the commit hash of the latest commit to the command, since we are interested in the changes after the first commit. Nice! By displaying the differences between commits, we identified another set of credentials. The approach of automating tasks with SSH pass is commonly used to provide a password in a non-interactive way for scripts. Before we conclude this section, let's make sure to add the username and password to creds.txt on our Kali machine. Let's summarize what we've achieved in this section. We used the LinP's automated enumeration script to identify potentially sensitive information and privilege escalation vectors. The script identified that user bin git can be run with sudo as the user Daniela, the WordPress directory is a Git repository, and a clear text password is used in the WordPress database settings. By abusing the sudo command, we successfully elevated our privileges. Then, we identified a previously removed bash script in the Git repository and displayed it. This script contained a new username and password. In the next learning unit, we'll structure and leverage the information we've obtained in an attack, which will provide access to the internal network. Domain credentials. In this section, we'll attempt to identify valid combinations of usernames and passwords on MailServe-1. Let's begin by using the current information in our creds.txt file to create a list of usernames and passwords. Let's begin by reviewing the current information in creds.txt. Based on the output, we'll create a list of usernames containing Marcus, John, and Daniela. Because WordPress is not a real user but is used for the database connection of the WordPress instance on WebServe-1, we'll omit it. In addition, we'll create a password list containing the following passwords. We now have two lists containing the usernames and passwords we've identified so far. Our next step is to use crackmapexec and check these credentials against SMB on MailServe-1. We'll specify continue on success to avoid stopping at the first valid credentials. Crackmapexec identified one valid set of credentials. This isn't much of a surprise since we retrieved the username and password from the staging script on WebServe-1. However, John could have changed their password in the meantime. The output shows another great crack map exec feature. It identified the domain name and added it to the usernames. This means that mailserve1 is a domain-joined machine, and we have identified a valid set of domain credentials. Now that we have valid domain credentials, we need to come up with a plan for our next steps. Reviewing the crack map exec output and the port scan for mailserve1, we don't have many options. We have identified the mail server and SMB, but no services such as WinRM or RDP. In addition, the scan showed that John is not a local administrator on mailserve1, as indicated by the missing pwned. This provides us with two options. We can further enumerate SMB on mailserve1 and check for sensitive information on accessible shares, or we can prepare a malicious attachment and send a phishing email as John to Daniela and Marcus. Let's choose option 1 first and leverage crackmapexec to list the SMB shares and their permissions on mailserve1 by providing shares and John's credentials. We may identify accessible shares containing additional information that we can use for the second option. crackmapexec only identified the default shares on which we have no actionable permissions. At this point, we only have the second option left, preparing an email with a malicious attachment and sending it to Daniela and Marcus. Let's summarize what we did in this section. First, we used the information we retrieved in the previous learning unit and leveraged it in a password attack against mailserve1. This password attack resulted in discovering one valid set of credentials. Then, we enumerated the SMB shares on mailserve1 as John without any actionable results. Phishing for access. In this section, we'll perform a client-side attack by sending a phishing email. Throughout this course, we've mainly discussed two client-side attack techniques: Microsoft Office documents containing macros and Windows library files in combination with shortcut files. Because we don't have any information about the internal machines or infrastructure, we'll choose the second technique, as Microsoft Office may not be installed on any of the target systems. For this attack, we have to set up a WebDAV server, a Python 3 web server, a Netcat listener, and prepare the Windows library and shortcut files. Let's begin by setting up the WebDAV share on our Kali machine on port 80 with WSGI DAV. In addition, we'll create the home, Kali, beyond WebDAV directory as the WebDAV root directory. Our WebDAV share is now served on port 80 with anonymous access settings. Now, let's connect to WinPrep via RDP as OffSec with a password of lab in order to prepare the Windows library and shortcut files. Once connected, we'll open Visual Studio Code and create a new text file on the desktop named config.libraryms. Now, let's copy the Windows library code we previously used in the client-side attacks module, paste it into Visual Studio Code, and check that the IP address points to our Kali machine. Let's save the file and transfer it to Home Kali Beyond on our Kali machine. Next, we'll create the shortcut file. For this, we'll right-click on the desktop and select New Shortcut. A victim double-clicking the shortcut file will download PowerCat and create a reverse shell. We can enter the following command to achieve this. Once we enter the command and install as shortcut file name, we can transfer the resulting shortcut file to our Kali machine into the webdav directory. Our next step is to serve PowerCat via a Python 3 web server. Let's copy PowerCat.ps1 to Home Kali Beyond and serve it on port 8000, as we specified in the shortcuts PowerShell command. Once the Python 3 web server is running, we can start a Netcat listener on port 4444 in a new terminal tab to catch the incoming reverse shell from PowerCat. With Netcat running, all services and files are prepared. Now, let's create the email. To send the email, we'll use the command line SMTP test tool SWAX. As a first step, let's create the body of the email containing our pretext. Because we don't have specific information about any of the users, we have to use something more generic. Fortunately, we obtained some information about the target company on WebServe1 within the Git repository. We'll create the body.txt file in Home Kali Beyond with the following text. Hopefully, this text will convince Marcus or Daniela to open our attachment. Now we are ready to build the SWAX command to send the emails. We'll provide Daniela@beyond.com and Marcus@beyond.com as recipients of the email to -t, John@beyond.com as name on the email envelope, sender, to from, and the Windows library file to attach. Next, we'll enter suppress data to summarize information regarding the SMTP transactions. For the email subject and body, we'll provide subject staging script to header and body.txt to body. In addition, we'll enter the IP address of mailserve1 for server. Finally, we'll add -AP to enable password authentication. Once entered, we have to provide the credentials for John. After waiting a few moments, we receive requests for our WebDAV and Python 3 web servers. Let's check the Netcat listener. Great! Our client-side attack via email was successful, and we obtained an interactive shell on a machine. Let's display the current user, host name, and IP address to confirm that we have an initial foothold in the internal network. The output shows that we landed on the Client Workstation 1 system as domain user Marcus. In addition, the IP address of the system is 172.16.6.243/24, indicating an internal IP range. We should also document the IP address and network information, such as the subnet and gateway in our workspace directory. Let's briefly summarize what we did in this section. First, we set up our Kali machine to provide the necessary services and files for our attack. Then, we prepared a Windows library and shortcut file on WinPrep. Once we sent our email with the attachment, we received an incoming reverse shell from Client Workstation 1 in the internal network. Situational awareness. In this section, we'll attempt to gain situational awareness on the Client Workstation 1 system and the internal network. First, we'll perform local enumeration on Client Workstation 1 to obtain an overview of the system and identify potentially valuable information and data. Then, we'll enumerate the domain to discover users, computers, domain administrators, and potential vectors for lateral movement and privilege escalation. Let's start with enumerating the Client Workstation 1 machine. Let's copy the 64-bit WinPs executable to the directory served by the Python 3 web server. On Client Workstation 1, we'll change the current directory to the home directory for Marcus and download WinPs from our Kali machine. Once downloaded, we'll launch it. Let's review some of the results provided by WinPs. We'll start with the Basic System Information section. The output shows that WinPs detected Client Workstation 1's operating system as Windows 10 Pro. As we have learned in the course, WinPs may falsely detect Windows 11 as Windows 10, so let's manually check the operating system with System Info. Indeed, Windows 11 is the operating system on Client Workstation 1. If we had blindly relied on the WinPs results, we may have made the wrong assumptions from the beginning. Going back to review the WinPs output, we come across the AV section. No AV has been detected. This will make the use of other tools and payloads such as Meterpreter much easier. Let's also review the network information such as network iFaces and known hosts and DNS cached. The results show that the DNS entries for mailserve1.beyond.com and dcserve1.beyond.com are cached on Client Workstation 1. Based on the name, we can assume that dcserve1 is the domain controller of the beyond.com domain. Furthermore, because mailserve1 is detected with the internal IP address of 172.16.6.254, and we enumerated the machine from an external perspective via 192.168.50.242, we can safely assume that this is a dual-homed host. As we did for credentials, let's create a text file named computer.txt in home Kali beyond to document identified internal machines and additional information about them. Reviewing the rest of the WinPs results, we don't find any actionable information to attempt a potential privilege escalation attack. However, we should remind ourselves that we are in a simulated penetration test and not in a CTF lab environment. Therefore, it is not necessary to get administrative privileges on every machine. Since we haven't identified a privilege escalation vector via WinPs, and there is nothing else actionable on the system, such as a password manager, let's start enumerating the AD environment and its objects. We learned several techniques in this course to perform this kind of enumeration. For this module, we'll use Bloodhound with the sharphound.ps1 collector, which we discussed in the Active Directory Introduction and Enumeration module. First, we'll copy the PowerShell collector to Home Kali Beyond in a new terminal tab to serve it via the Python 3 web server on port 8000. Since our Python 3 web server is still running on port 8000, we can download the PowerShell script on the target machine and import it in a newly spawned PowerShell session with the execution policy set to bypass. Now, we can execute invoke Bloodhound by providing all to -collection method to invoke all available collection methods. Once sharphound has finished, we can list the files in the directory to locate the zip archive containing our enumeration results. Let's transfer the file to our Kali machine, then start Neo4j and Bloodhound. Once Bloodhound is started, we'll upload the zip archive with the upload data function. Once the upload is finished, we can start the enumeration of the AD environment with Bloodhound. Before we start, let's briefly review some of Bloodhound's capabilities. As we have learned, Bloodhound contains various pre-built queries, such as find all domain admins. These queries are built with the Cypher query language. In addition to the pre-built queries, Bloodhound also allows us to enter custom queries via the raw query function at the bottom of the GUI. Since we are currently interested in basic domain enumeration, such as listing AD users and computers, we have to build and enter custom queries, as the pre-built functions don't provide these capabilities. Let's build a raw query to display all computers identified by the collector. The query starts with the keyword match, which is used to select a set of objects. Then, we set the variable m containing all objects in the database with the property computer. Next, we use the return keyword to build the resulting graph based on the objects in M. Let's enter this query in the raw query section and build the graph. There are 4 computer objects in the domain. By clicking on the nodes, we can obtain additional information about the computer objects, such as the operating system. In addition to Client Workstation 1, on which we have an interactive shell, Bloodhound has also identified the already known domain controller DCServe1 and dual-homed mail server MailServe1. Furthermore, it discovered another machine named InternalServe1. Let's obtain the IP address for InternalServe1 with NSLOOKUP. The IP address for InternalServe1 is 172.16.6.241. Let's add this information to computer.txt on our Kali machine. Next, we want to display all user accounts on the domain. For this, we can replace the computer property of the previous query with user. Apart from the default AD user accounts, there are 4 other user account objects in the domain: Becky, John, Daniela, and Marcus. We already identified John and Marcus as valid domain users in previous steps. However, we haven't established yet if Daniela is also a domain user and not just a local user on WebServe 1. In addition, we discovered a new user named Becky. Let's update usernames.txt accordingly. To be able to use some of Bloodhound's pre-built queries, we can mark Marcus, which has the interactive shell on Client Workstation 1, and John, for which we have valid credentials, as owned. To do this, we'll right-click on the Marcus@beyond.com and John@beyond.com nodes and select Mark User as Owned. Next, let's display all domain administrators by using the pre-built Find All Domain Admins query under the Analysis tab. Apart from the default domain administrator account, Becky is also a member of the Domain Admins group. Next, let's use some of the pre-built queries to find potential vectors to elevate our privileges or gain access to other systems. We'll run the following pre-built queries. Find workstations where domain users can RDP. Find servers where domain users can RDP. Find computers where domain users are local admin. Shortest path to domain admins from owned principals. Unfortunately, none of these queries return any results. This means Bloodhound didn't identify any workstations or servers where domain users can log in via RDP. In addition, no domain users are a local administrator on any computer objects. Therefore, we don't have privileged access on any domain computers as John or Marcus. Finally, there are no direct paths from owned users to the domain admins group that Bloodhound could identify. These pre-built queries are often a quick and powerful way to identify low-hanging fruit in our quest to elevate our privileges and gain access to other systems. Because Bloodhound didn't provide us with actionable vectors, we have to resort to other methods. Before we further enumerate the domain in the next section, let's summarize the information we've obtained so far. We identified 4 computer objects and 4 user accounts and learned that Becky is a member of the Domain Admins group, making it a high-value target. Furthermore, we ruled out some vectors that would have provided us access to other systems or privileged users. Services and Sessions. In the previous section, we performed basic enumeration to obtain an understanding of the Active Directory environment. In this section, we'll further enumerate the target network to identify potential attack vectors. First, we'll review all active user sessions on machines. Then, we'll examine user accounts for the existence of SPNs. Finally, we'll leverage tools such as Nmap and crackmapexec via a SOC 5 proxy to identify accessible services. To review active sessions, we'll again use a custom query in Bloodhound. Since Cypher is a querying language, we can build a relationship query with the following syntax. The relationship for our use case is hasSession. The first node of the relationship specified by a property is cComputer, and the second is mUser, meaning the edge between the two nodes has its source at the computer object. We'll use P to store and display the data. Now, let's enter the custom query. Our query resulted in 3 active sessions. As expected, Client Workstation 1 has an active session with the user Marcus. Interestingly, the previously identified domain administrator account Becky has an active session on MailServe 1. If we manage to get privileged access to this machine, we can potentially extract the NTLM hash for this user. The user of the third active session is displayed as a SID. Bloodhound uses this representation of a principal when the domain identifier of the SID is from a local machine. For this session, this means that the local administrator, indicated by RID 500, has an active session on internal serve 1. Our next step is to identify all Kerberoastable users in the domain. To do so, we can use the List All Kerberoastable Accounts pre-built query in Bloodhound. Apart from KerbTGT, Daniela is also Kerberoastable. Let's examine the SPN for Daniela via the Node Info menu by clicking on the node. The output shows the mapped SPN http internalserve1.beyond.com. Based on this, we can assume that a web server is running on internal serve 1. Once we've performed Kerberoasting and potentially obtained the plaintext password for Daniela, we may use it to access internal serve 1. However, as we have stated before, finding an actionable vector should not interrupt our enumeration process. We should collect all information, prioritize it, and then perform potential attacks. Therefore, let's set up a SOC 5 proxy to perform network enumeration via Nmap and crackmapexec in order to identify accessible services, open ports, and SMB settings. First, we'll create a staged interpreter TCP reverse shell as an executable file with MSF Venom. Because we can reuse the binary throughout the domain, we can store it in home, Cali, beyond. Now, let's start a multi-handler listener with the corresponding settings in Metasploit. In addition, we'll set the option Exit on Session to False. It specifies that the listener stays active for new sessions without the need to restart it for every incoming session. Next, we can download and execute met.exe on Client Workstation 1. In Metasploit, a new session should appear. Once session 1 is opened, we can use multi-manage autoroute and auxiliary server SOCKS proxy to create a SOCKS 5 proxy to access the internal network from our Kali box, as we learned in the Metasploit Framework module. The SOCKS 5 proxy is now active, and we can use proxy chains to access the internal network. Let's confirm that the etc proxychains4.conf file still contains the necessary settings from previous modules, meaning only the SOCKS 5 entry from the following listing should be active. Finally, we are set up to enumerate the network via proxy chains. Let's begin with crackmapexec's SMB module to retrieve basic information of the identified servers, such as SMB settings. We'll also provide the credentials for John to list the SMB shares and their permissions with shares. Because crackmapexec doesn't have an option to specify an output file, we'll copy the results manually and store them in a file. The output shows that John doesn't have actionable or interesting permissions on any of the discovered shares. As we've already established via a pre-built Bloodhound query, and now through the scan, John as a normal domain user doesn't have local administrator privileges on any of the machines in the domain. The output also states that mailserve1 and internal serve1 have SMB signing set to false. Without this security mechanism enabled, we can potentially perform relay attacks if we can force an authentication request. Next, let's use Nmap to perform a port scan on ports commonly used by web applications and FTP servers targeting mailserve1, DCserve1, and internal serve1. We have to specify -ST to perform a TCP connect scan. Otherwise, Nmap will not work over proxy chains. The results show that Nmap identified the open ports 80 and 443 on internal serve1 and port 80 on mailserve1. While we could use the SOCKS 5 proxy and proxy chains to browse to the open port on 172.16.6.241, we'll use Chisel as it provides a more stable and interactive browser session. From the Releases page, we'll download the Windows and Linux AMD 64 versions and extract the binaries in Home, Kali, Beyond. On our Kali machine, we'll use Chisel in server mode to receive incoming connections on port 8080. In addition, we'll add the reverse option to allow reverse port forwarding. Then, we'll transfer the extracted chisel.exe binary to Client Workstation 1 by using Meterpreter's upload command. Now, we can enter Shell and utilize Chisel in client mode to connect back to our Kali machine on port 8080. We'll create a reverse port forward with the syntax R, local port, remote host, remote port. In our case, the remote host and port are 172.16.6.241 and 80. The local port we want to utilize is 80. Once Chisel connects, we can browse to port 80 on 172.16.6.241 via port 80 on our Kali machine by using Firefox. The output is a WordPress instance indicated by the URL and title of the page on internal serve 1. Let's browse to the dashboard login page for WordPress and try to log into it with the credentials we've discovered so far. Unfortunately, the page doesn't load and a PHP file is downloaded. Because our machine doesn't have information about this DNS name, we cannot connect to the page. To be able to fully use the web application, we'll add internalserve1.beyond.com to Etsy hosts. Now, let's open the WP admin page again. The login page is now displayed correctly. Let's try to log in with the credentials we've obtained so far, as well as common username and password pairs, such as admin. Unfortunately, none of them work. Let's summarize the information we've gathered in this section before we attempt our attacks. First, we enumerated all active sessions. Interestingly, the domain administrator Becky has an active session on MailServe 1. Next, we identified Daniela as a Kerberoastable user due to the http internalserve1.beyond.com SPN. Then, we set up a SOCKS 5 proxy with Metasploit and used crackmapexec and nmap to perform network enumeration. the output revealed that MailServe1 and InternalServe1 each have an accessible web server and SMB signing disabled. While MailServe1 only displayed a default page, InternalServe1 serves a WordPress instance. However, none of the credentials worked to log in to the WordPress login page. Speak Kerberoast and enter. Based on the information from the previous learning unit, the web application on InternalServe1 is the most promising target at the moment. Because it is a WordPress site, we could use WP Scan again or use password attacks to successfully log in to WordPress's dashboard. Every time we obtain new information, we should reevaluate what we already know. For our situation, this means that we already obtained the information that Daniela has an HTTP SPN mapped to InternalServe1. Our assumption at this point is that Daniela may be able to log in to the WordPress login page successfully. Since Daniela is Kerberoastable, we can attempt to retrieve the user's password this way. If we can crack the TGS rep password hash, we may be able to log in to WordPress and gain further access to InternalServe1. If this attack vector fails, we can use WP Scan and other web application enumeration tools to identify potential vulnerabilities on InternalServe1 or switch targets to MailServe1. Let's perform Kerberoasting on Kali with Impacket Get User SPNs over the SOCKS5 proxy using proxy chains. To obtain the TGS rep hash for Daniela, we have to provide the credentials of a domain user. Because we only have one valid set of credentials, we'll use John. Let's store the hash in home Kali beyond Daniela.hash and launch Hashcat to crack it. Very nice. We successfully cracked the TGS rep hash and obtained the plain text password for Daniela. Let's store the username and password in creds.txt. Next, let's try to log into WordPress at WP admin via Firefox and proxy chains. Great! We successfully logged in to the WordPress instance as Daniela. In the next section, we'll leverage this access to gain access to another system. Abuse a WordPress plugin for a relay attack. In the previous section, we retrieved the plaintext password for Daniela and gained access to the WordPress dashboard on InternalServe1. Let's review some of the settings and plugins. We'll begin with the configured users. Daniela is the only user. Next, let's check Settings, General. The WordPress address URL and site address URL are DNS names, as we assumed. All other settings in Settings are mostly default values. Let's review the installed plugins next. Three plugins are shown, but only backup migration is enabled. Let's click on Manage, which brings us to the plugin configuration page. Clicking through the menus and settings, we discover the backup directory path. We can enter a path in this field, which will be used for storing the backup. We may abuse this functionality to force an authentication of the underlying system. Let's pause here for a moment and plan our next steps. At the moment, there are two promising attack vectors. The first is to upload a malicious WordPress plugin to internal serve 1. By preparing and uploading a web shell or reverse shell, we may be able to obtain code execution on the underlying system. For the second attack vector, we have to review the Bloodhound results again and make some assumptions. As we have discovered, the local administrator account has an active session on internal serve 1. Based on this session, we can make the assumption that this user account is used to run the WordPress instance. Furthermore, it's not uncommon that the local administrator accounts across computers in a domain are set up with the same password. Let's assume this is true for the target environment. We also learned that the domain administrator Becky has an active session on MailServe 1, and therefore, the credentials of the user may be cached on the system. Due to SMB signing being disabled on MailServe 1 and internal serve 1, a relay attack is possible if we can force an authentication. Finally, we identified the Backup Directory Path field in the WordPress Backup Migration plugin containing the path for the backup destination. This may allow us to force such an authentication request. Based on all of this information, let's define a plan for the second attack vector. First, we'll attempt to force an authentication request by abusing the backup directory path of the Backup Migration WordPress plugin on internal serve 1. By setting the destination path to our Kali machine, we can use impacket NTLM relay X to relay the incoming connection to MailServe 1. If our assumptions are correct, the authentication request is made in the context of the local administrator account on internal serve 1, which has the same password as the local administrator account on MailServe 1. If this attack is successful, we'll obtain privileged code execution on MailServe 1, which we can then leverage to extract the NTLM hash for Becky, and therefore meet one of the primary goals of the penetration test. Since the second attack vector not only results in code execution on a single system, but also provides a potential vector to achieve one of the goals of the penetration test, we'll perform the relay attack first. Let's set up impacket NTLM relay X before we modify the backup directory path in the WordPress plugin. we'll use no HTTP server and -SMB2 support to disable the HTTP server and enable SMB2 support. We'll specify the external address for mailserve1 as target for the relay attack. By entering the external address, we don't have to proxy our relay attack via proxy chains. Finally, we'll base64 encode a PowerShell reverse shell one-liner that will connect back to our Kali machine on port 9999 and provide it as a command to -C. Next, we'll set up a netcat listener on port 9999 for the incoming reverse shell. Now, with everything set up, we can modify the backup directory path. Let's set the path to the URI reference 192.168.118.4/test, in which the IP is the address of our Kali machine and test is a non-existent path. Once entered, we can scroll down and click on Save. This should cause the WordPress plugin to authenticate to impacket-ntlm relay X in the context of the user running WordPress. The output confirms the assumptions we made earlier. First, internal serve1/administrator was used to perform the authentication. Second, by successfully authenticating to mailserve1, we confirmed that both machines use the same password for the local administrator account. The output also states that the relayed command on mailserve1 got executed. Let's check our netcat listener for an incoming reverse shell. Great! We successfully obtained code execution as NT Authority System by authenticating as a local administrator on mailserve1 by relaying an authentication attempt from the WordPress plugin on internal serve1. In the next learning unit, we'll leverage the interactive shell on mailserve1 to obtain privileged access to the domain and its domain controller. Cached credentials. As planned, we obtained privileged code execution on mailserve1. Our next step is to extract the password hash for the user Daniela, which has an active session on this system. Once we discover that no AV is running, we should upgrade our shell to Meterpreter. This will not only provide us with a more robust shell environment, but also aid in performing post-exploitation. Let's download the previously created Meterpreter reverse shell payload met.exe to perform post-exploitation. In Metasploit, we should receive a new incoming session. Let's interact with the session and spawn a new PowerShell command line shell. Next, we'll download the current Mimikatz version on Kali and serve it via our Python 3 web server on port 8000. On mailserve 1, we'll download Mimikatz with IWR and launch it. Once Mimikatz is launched, we can use privilege debug to obtain scdebug privilege. Then, we can use secure LSA logon passwords to list all provider credentials available on the system. Great! We successfully extracted the NTLM hash of the domain administrator, Becky. Let's store it together with the username in creds.txt on our Kali system. Armed with this hash, we can now take the last step of the penetration test, accessing the domain controller. We'll do this in the next section. Lateral movement. In this section, we'll leverage the domain admin privileges for Becky to get access to the domain controller and therefore achieve the second goal of the penetration test. Because we've obtained the NTLM hash for Becky, we can use impacket-psexec to get an interactive shell on DCServe1. Once we have a command line shell, we confirm that we have privileged access on DCServe1. Nice! We achieved all goals of the penetration test by obtaining domain administrator privileges and accessing the domain controller.